Vidyanagar online science class. Today I am going to discuss with you the very important concepts from our second chemistry chapter is matter around us pure. At the end of today's module you will learn about elements, compounds and their differences. Let's move to today's class. Okay. Matter in around us can be classified into pure substances and mixtures. Matter around us mainly classified into pure substances and mixtures. What are pure substances? Pure substances are the substances which contain only single type of substances or same type of substances. So in chemistry, we define pure substance as the substances which contain only one type of substances. What are mixtures? Mixtures constituted by two or more same kind of pure substances. Mixtures are mixtures contains two or more pure form of matters. And mixtures can be classified into homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are the mixtures which contain uniform composition everywhere, and heterogeneous mixtures are the mixtures which contain heterogeneous or non-uniform composition everywhere. These are the points we discussed in our previous class. And now we are about to discuss what are the classification of pure substances. Pure substances mainly classified into elements and compounds. We can classify the pure substances into elements and compounds. Which are the classification of pure substance? Pure substances mainly divided into two, elements and compounds. First we can discuss about elements. Elements. Robert Boyle was the first scientist to use the term element in the year 1661. In the year 1661, the scientist named Robert Boyle used the term element first. Who used the term element first? Robert Boyle. Robert Boyle was the first scientist to use the term element. So in the year 1661, Robert Boyle identified the element. Robert Boyle identified the existence of elements. And after many years later, another scientist, Lavoisier, Anthony Laurent Lavoisier, gave a correct explanation or definition to element. Boyle just identified the presence of elements. He couldn't give any definition to element. But Anthony Laurent Lavoisier gave a definition to element. Who gave definition to element? Anthony Laurent Lavoisier. Who identified or who used the term element first? Robert Boyle. According to Lavoisier, element is the basic form of matter that cannot be further broken down into simpler pieces in any chemical reactions. According to Lavoisier, elements are the basic form of matter that cannot be further broken down into simpler particles or simpler forms in chemical reactions. This was the definition given by Lavoisier, which means elements itself very small and we cannot divide this small substance again into simpler forms. So that was the definition given by Lavoisier. According to Lavoisier, elements are the basic form of matter that cannot be further broken down into simpler particles or simpler forms in a chemical reactions, which means elements are small. These small particles cannot be broken down into simpler ones by Lavoisier. Why element can be considered as a pure form or pure substance? Why elements are the examples of pure substances? Because you can see some examples of elements on the board like sodium, potassium, silver, gold, etc. What are pure substances? Pure substances are the substance which contain single type of particles or single substances, right? So when we talk about sodium, the sodium contains only sodium particles, potassium contains only potassium particles, gold contains only gold particles. So they are examples of pure substances. As a whole, elements are pure substances. Okay, so what are elements? Elements are the basic form of matter that cannot be again divided into simpler forms in a chemical reaction.
Robert Boyle was the first scientist to use the term element. Later, Anthony Laurent Lavoisier defined the element. According to Lavoisier, elements is the basic form of matter that cannot be broken down into simpler substances by chemical reactions. Examples: sodium, potassium, aluminium, gold, etc.
As I told you, Robert Boyle was the first scientist to use the term element, or he identified the term element first. Later, Anthony Laurent Lavoisier gave a definition to element. According to Lavoisier, elements are the basic forms of matter that cannot be broken down into simpler substances by a chemical reaction. Elements can be classified into three. Elements can be classified into three, and they are metals, non-metals and metalloids. So which are the classification of elements? Elements can be classified into three: metals, non-metals and metalloids. We discussed about metals and non-metals in 8th standard. Are you remembering that? Which are the physical properties of metals and non-metals? Just recollect it. Metals are lustrous, metallic luster. Metals are shiny. So that shining property of the metal is metallic luster. Metals can be beaten into thin sheets, which means malleability. Metals are malleable. Metals can be beaten into thin sheets, that is malleability. Metals can be drawn into wires, ductility. Metals are ductile. Metals are sonorous. On striking somewhere, metal produces ringing sound. That is, metals are sonorous. Metals are the good conductors of heat and electricity. And what about non-metals? Non-metals are dull in appearance. Non-metals are not malleable, not ductile. They are not sonorous, and they are poor conductors of heat and electricity. And there are some substances or materials which shows the properties of metals and non-metals. They are the intermediate of metals and non-metals, which means they shows both the properties of metals and non-metals. They are metalloids. So metalloids are between the metals and non-metals because they shows the properties of metals and non-metals. Examples of metalloids are boron, germanium, silicon, etc. because they shows the properties of metals and non-metals, and they are metalloids. What are compounds? Compound is a substance composed of two or more elements chemically combined together with one another in a fixed proportion. So what are compounds? Compounds are the substances composed of two or more elements chemically combined with one another in a fixed proportion. Compounds are the substances composed of two or more elements chemically combined with one another in a fixed proportion. For example, say H2O. H2O means water. This is the molecular formula for water. Wherever we go, we can use same H2O for water. Which means there is 2 hydrogen and 1 oxygen in water. We cannot change that. You can use only 2 hydrogen and oxygen for water, that is fixed proportion. In a compound, elements are fixed. Compound is composed of fixed proportion of elements. We cannot change that proportions. If there is water, there should be 2 hydrogen and 1 oxygen. Suppose if you write 2 hydrogen and 2 oxygen, you will get another product named hydrogen peroxide. So for the water, you can use this. You can use this only for water. Why? Because 2 hydrogen and 1 oxygen in water, and if it is 2 hydrogen and 2 oxygen, that is hydrogen peroxide. So in a compound, elements are in a fixed proportion. For example, in water, 2 hydrogen and 1 oxygen, that is fixed. Here 2 hydrogen, 2 oxygen, that is fixed. And in carbon dioxide, 1 carbon, 2 oxygen, and in carbon monoxide, 1 carbon, 1 oxygen. So we cannot change the proportion of elements in a compound, that is fixed. If we change the proportion, we will get another compounds. Like in H2O, 2 hydrogen, 1 oxygen. If you write 2 hydrogen and 2 oxygen, you will get hydrogen peroxide. So in a compound, elements are present in fixed proportion. If we change the proportion, we will get another compound, which means in an element, in a compound, elements are present in a fixed proportion, like 2 hydrogen and oxygen in water, 1 carbon, 2 oxygen in carbon dioxide, 1 carbon, 1 oxygen in carbon monoxide. So how to define a compound? Compounds are the substances composed of 2 or more elements chemically combined with one another in a fixed proportion. Wherever we go, we can use these compounds. You see, if we changes the station, there is no change in the proportion of the elements. That proportion of the elements same everywhere. Like water, here and in any other state, we will write same molecular formula for water, because in a compound, elements are present in a fixed proportion. We cannot change this proportion, because if we try to change the proportion, it will lose the identity of the compound and we will get the new one. So compounds are the substances composed of 2 or more elements chemically combined with one another in a fixed proportion. Okay, then how to differentiate elements and compounds? How to differentiate elements and compounds? Elements are the basic form of matter that cannot be further broken down into simpler substances. But compounds are, in a compound, elements are present in fixed proportion. Elements are present in a fixed proportion, and we can broken down the compounds into elements. Compounds breakdowns to give elements. Compounds breakdowns to form elements. See example. Carbon dioxide is a compound because carbon and oxygen in a fixed proportion. Carbon dioxide is a compound. Compound split up to form carbon and oxygen. Carbon and oxygen elements. Carbon monoxide is a compound. On breaking, carbon and oxygen elements, which means compounds split up to form elements, but elements cannot be further broken down into simpler forms, which is the base, main difference between elements and compound. So what are the differences between elements and compounds? Elements are the basic form of matter that cannot be further broken down into simpler substances by chemical reaction. And compounds are the substances composed of 2 or more elements chemically combined with one another in a fixed proportion, and compounds can be broken down into elements. Compounds split up to give corresponding elements.
Differences between mixtures and compounds. Mixtures. Elements or compounds just mix together to form a mixture and no new compounds is formed. Compounds. Elements react to form new compounds. For example, if you want to make the mixture of sugar and salt, we just mix them together. we have to mix the salt and sugar simultaneously, which means in order to make the mixture we don't want to do any chemical reaction, just we have to mix them. But in case of compounds, when carbon react with oxygen to form carbon dioxide, there is a chemical reaction behind the formation of carbon dioxide. So carbon dioxide is a new product, and the carbon dioxide entirely different from the carbon and oxygen. But in case of mixture, if you want to make a mixture, we just mix them and stir them thoroughly. We don't want to heat them, we don't want to conduct any experiments, or we don't want to do any reaction, etc. In order to make a mixture, just we have to mix them. So when we mix these two components like salt and sugar, we get them. So that mixture gives both the taste of salt and sugar, which means that mixture shows the properties of the component inside the mixers like salt and sugar. So mixing of 2 or 3 substances gives mixture, and when 2 or 3 elements taking part in the chemical reactions, and we get the compounds. Okay, and the second one, a mixture has variable composition. The composition of each new substance is always fixed in compounds. So in mixture, a mixture has a variable composition, and in compound, the composition of each new substance is always fixed. For example, if a mixture contains 2 teaspoonful of salt and 1 teaspoonful of sugar, which taste we will get more? While tasting the mixture, we will get the salty taste more. Why? Because we added 2 teaspoons of salt and 1 teaspoon of sugar, right? Which means that mixture contains more amount of salt and less amount of sugar. So definitely that mixture gives the taste of the more component, which means variable composition. Variable composition means what? Two components are there, salt and sugar. Salt is more than that of the sugar. So different composition of the components. That means mixture shows variable composition. But in case of compounds, you see that we discussed earlier. Suppose water contains 2 hydrogen and 1 oxygen, and hydrogen peroxide contains 2 hydrogen and 2 oxygen. That is fixed. Wherever we go, we have to use the same formula. It means the composition in compounds are fixed. So mixture has variable composition, and the composition of each new substance is always fixed in compounds. Third one, a mixture shows the properties of the constant substances. The new substance has totally different properties, compounds. A mixture shows the properties of the constant substances, which means, just I told you, if a mixture contains salt and sugar, we get the taste of sugar and salt. So that is the constant particles in the mixture. So the mixture gives the composition of or the properties of the constant substances. In simple way, if we taste the solution which contain sugar and salt, we will get the taste of sugar as well as salt, because these two components are there. So if a solution contains some constants or components, we will get the taste of that components in mixture, because in mixture just we are mixing only, there is no reaction, nothing. So we will get the properties of constant particles in the mixture. Suppose in case of compounds, I told you carbon react with oxygen to form carbon dioxide. So what happens there? Carbon react with oxygen to form a new product. So there is a chemical reaction behind this. So after the chemical reaction, we get a product, a new product. That new product is entirely different from the particles or the reactants. Here the reactants like carbon and oxygen react with the carbon react with oxygen to form carbon dioxide. So after the formation, when we check the properties of carbon dioxide and carbon and oxygen, we can see there carbon dioxide is entirely different from carbon and oxygen, because carbon dioxide formed by the reaction, or the compounds formed by a chemical reaction. After the chemical reaction, the properties of the products and the reactants. Reactants means the materials which taking part in the chemical reaction, and the products after the reaction what we get, they are the product. So after the reaction, the properties of the reactants and properties of the products are entirely different, because that is due to the chemical reactions between the reactants and the products. And the last one, the constituents can be separated fairly easily by physical methods in mixtures, and the constituents can be separated only by chemical or electrochemical reactions. So it is enough for physical processes is enough for mixtures, because there is no reaction, just we are mixing. So like filtration and other evaporation etc., it is possible in case of mixtures, but in case of compounds there is a chemical reaction. So instead of using physical processes, we have to use the chemical processes in case of compounds. So these are the properties of or differences of mixtures and compounds. So matter mainly divided into pure substance and mixtures. Pure substance again divided into elements and compounds, and mixtures divided into homogeneous and heterogeneous. Elements and compounds. Elements cannot be broken down into simpler substances. Compounds have fixed composition, can be broken down into elements by chemical or electrochemical processes. For example, for elements copper, oxygen, iron, hydrogen, etc. Compounds water, methane, sugar, salt, etc. Homogeneous and heterogeneous. Homogeneous uniform composition, heterogeneous non-uniform composition. For example, sugar in water, salt in water, etc. For example, for heterogeneous, sand and salt mixture.
That's all about today's class. Watch the video carefully. We will meet you again with another video. Thank you for watching. Have a wonderful day ahead.